Why does the moon have two completely different faces? One side is smooth and dark, the other rugged and battered. The answer lies in a story of cosmic violence. Billions of years ago, a giant asteroid slammed into the moon, reshaping its destiny. The near side, always facing Earth, is covered with dark volcanic plains called maria, evidence of ancient lava flows. The far side, hidden from view until the space age, is a chaotic landscape of craters and highlands, almost devoid of maria. Scientists long suspected the difference was due to crust thickness. The near side's thinner crust allowed magma to surface, while the far side's thick crust kept it locked away. But what caused this crustal imbalance? The answer points to a single, monumental impact. The moon's two faces are a record of its violent youth, a detective story written in rock and crater. By studying these scars, we unlock secrets of the early solar system, preserved on the moon while erased from Earth. Deciphering the moon's past is like reading a lost chapter of our own origin story. To solve the moon's mystery, we needed samples from its far side, a feat achieved by China's Chang'e 6 mission. The far side never faces Earth, so China launched a relay satellite to maintain contact with the lander. Chang'e 6 targeted the South Pole Aitken basin, the largest and oldest impact crater on the moon, ground zero for the ancient collision. The lander collected both surface soil and a core sample, capturing material possibly ejected from deep within the moon. In June 2024, the return capsule landed safely in Inner Mongolia, bringing humanity its first samples from the moon's hidden hemisphere. These rocks are more than souvenirs. They're time capsules, holding chemical clues to the moon's formation. Their analysis promises to rewrite our understanding of lunar history. How can a handful of rocks reveal a billion-year-old impact? The answer is in their isotopes, chemical fingerprints that trace the moon's history. Elements like potassium, thorium, and uranium have isotopes that act as tracers, revealing the processes that shaped the moon. A group called CREEP, potassium, rare earth elements and phosphorus, was key. CREEP is linked to the last remnants of the moon's primordial magma ocean. Apollo samples showed CREEP concentrated on the near side, suggesting it stayed hotter and more volcanically active. The far side, with little CREEP, cooled faster and developed a thicker crust. Chang'e 6's samples from the South Pole Aitken basin were the ultimate test. Scientists found the far side rocks had far less CREEP than those from the near side. This was the smoking gun. The moon's mantle is chemically asymmetric. The two faces of the moon are fundamentally different, not just on the surface, but deep within. This discovery confirmed the moon's split personality is rooted in its very core. The evidence now points to a single, colossal impact as the cause of the moon's dual nature. Billions of years ago, a massive object struck the moon's southern hemisphere, creating the South Pole Aitken basin. The impact punched through the crust, dredging up mantle material and blasting it across the surface. But it also sent a plume of heat and CREEP-rich material through the moon's interior, concentrating it on the near side. This made the near side hotter, thinner, and more volcanic, while the far side cooled quickly and grew a thick, rigid crust. The result? One moon, two worlds, each shaped by the aftermath of a single, ancient cataclysm. Chang'e 6's findings reveal how this impact fundamentally rewired the moon's geology. The moon's two faces are the legacy of a world-changing collision. The moon's story is more than a lunar mystery. It's a window into planetary evolution, including Earth's. While Earth's early history is lost to time, the moon preserves a pristine record of ancient cataclysms. Understanding how a single impact reshaped the moon helps us rethink how planets form and evolve. These findings also guide future exploration. Knowing the moon's resources are unevenly distributed is vital for planning missions and lunar bases. The South Pole Aitken Basin could be a treasure trove for science and future explorers. As we prepare to return to the moon, each new discovery brings us closer to understanding our place in the cosmos. The moon is not just a destination, it's a stepping stone to humanity's future among the stars.